Dear students, most welcome to my statistics class. This is Mohammad Ashraful Azim, lecturer in statistics, Rajagopura Model College. Today, we are going to discuss on third chapter of statistics first paper, which is measures of central tendency. This is the third chapter of statistics first paper, and the name of the chapter is measures of central tendency. So, in this chapter, we'll learn about the measures of central tendency, different types of measures of central tendency. Therefore, now onward, I'm going to discuss okay. Firstly, what is central tendency? The tendency of a distribution to cluster around a central value is called central tendency. To cluster around a central value, the tendency to cluster around a central value, that is known as central tendency. Now, measures of central tendency. What is measures of central tendency? Especially by which statistical system or by which statistical procedure we measure the central tendency, that is known as measures of central tendency. So here, by which statistical method we measure the central tendency is called measures of central tendency. Now, types of measures of central tendency. Especially, there are 5 types of measures of central tendency, which are arithmetic mean, geometric mean, harmonic mean, median, and mode. Normally, arithmetic mean is known as simply mean or average. You know about average, which is average, that is arithmetic mean. Sometimes shortly it is known as mean. Now, what is arithmetic mean? If sum of data is divided by number of data, then it is called arithmetic mean. So, similarly, we may write such a way that when x1, x2 up to xn be n values of a set of observations, then their arithmetic mean is denoted by x bar. So, the arithmetic mean of x1, x2, x3 up to xn be x bar, which is equal to x1 plus x2 plus x3 plus up to plus xn divided by n, which is shortly written as x bar equal to summation xi divided by n, where I equal to 1 to n. And this is for non-classified data. Again, if x1, x2, x3 up to xn be n values of a set of observation and f1, f2, f3 up to fn be their respective frequencies, in that moment arithmetic mean x bar equal to f1 x1 plus f2 x2 plus f3 x3 plus up to fn xn divided by capital N. This is divided by capital N, and it will be f1 x1 f2 x2 plus f3 x3 plus up to plus fn xn divided by capital N. So it is written such way that x bar equal to summation fi xi divided by capital N. This is for classified data. So for classified data and for non-classified data, we can define arithmetic mean in such a way. And if the data is presented in a frequency distribution table, in that moment, to determine arithmetic mean, we will use x bar equal to summation fi xi divided by capital N. The second measure of central tendency is geometric mean. Firstly, if in a set of data there's any value which is 0, in that moment we can't determine the geometric mean. Again, if there are odd numbers, negative values, in that moment we also can't determine the geometric mean. That is why geometric mean, to determine geometric mean, the set of data must be non-zero positive values. Now, what is geometric mean? The nth root of the product of n non-zero positive values is called geometric mean. Let us consider x1, x2, x3 up to xn be n values of a set of observation, and gm be their geometric mean. Then the geometric mean is defined such way that gm equal to nth root x1, x2, x3 up to xn. This is for non-classified data. Now for classified data, when x1, x2, x3 up to xn be n values of a set of observation, and f1, f2, f3 up to fn be their respective frequencies, in that moment the geometric mean is gm equal to nth root x1 to the power f1 into x2 to the power f2 up to x3 to the power f3 dash dash xn to the power fn. Now harmonic mean. What is harmonic mean? The reciprocal of the average of the reciprocal of non-zero positive value is called harmonic mean. Now for non-classified data, when x1, x2 up to xn be n values of a set of observations, Sm be their harmonic mean, then harmonic mean Sm equal to 1 divided by 1 by x1 plus 1 by x2 plus up to plus 1 by xn divided by n. Again, when x1, x2, x3 up to xn be n values of a set of observation, and f1, f2 up to n be their respective frequencies, then the harmonic mean will be Sm equal to 1 divided by f1 divided by x1 plus f2 divided by x2 plus up to plus fn divided by xn divided by n. Now median. We have to arrange the data, and after arranging, the middlemost value is median. So the middlemost value of an arranged data is called median. And in case of non-classified data, the median is n plus 1 divided by 2 term when n is odd. Again, if n is even, that is, if the number of observation is even, in that moment, median is n divided by 2 term plus n divided by 2 plus 1 term divided by 2. And for classified data, median is L plus n divided by 2 minus FC divided by FM into C, where L is lowest value of median class, N means total frequencies, FC means cumulative frequency of pre-median class, FM frequency of median class, and C is class interval. And last measure of central tendency is mode. The value which is repeated maximum time, which we get maximum time in a set of data, that is mode. In a set of data, there may be no mode, there may be one mode, there may be more than one mode. So uh, for non-classified data, if we get any value, highest time, maximum time, that will be the mode. And for classified data, mode is explained such way that mode, it is normally denoted by MO, which is L plus F1 divided by F1 plus F2 into C, where L be the lowest value of model class, F1 be the difference of frequency of model class and pre-model class, Fm is difference of frequency of model class and post-model class, and CB the class interval. So this is all about today's class. In this class, we understood that the uh, measure of central tendency. First, we understood what is central tendency. Later on, what is measures of central tendency. What are the different types of measures of central tendency we explained. So, no more today. In the next class, we'll explain the merits and demerits of the measures of central tendency, and we'll explain the different important characteristics of properties of arithmetic mean. So, no more today, dear students. Thank you very much. Allah Hafiz.